everyone, my name is Mr. Gilbert M. Acompañado, or you can call me Mr. Gibbs, welcoming you to our virtual class. Before we begin, I want you to prepare a pen, a notebook, and your printed module. Just pay attention, be relaxed, for this topic that we are going to tackle is very interesting and challenging in dealing with your day-to-day life. Our most essential competency is use the distance formula. The objectives: first, derive the distance formula. Second, determine the distance between the 2 points.
Few moments later.
Distance formula here is not the same with the distance that we are talking in your science subject that requires speed and time. But technically, the two are somehow the same in getting the numerical measurement of how far an object is from a particular place. So what is the distance formula that we'll be talking here? So to understand the distance formula, let us watch the presentation. The distance formula is a non-negative measure that is used to find the distance between 2 points, whether it is aligned horizontally or vertically, which can be represented as points x sub 1, y sub 1, and x sub 2, y sub 2. So to get the distance of a horizontal line or a horizontal distance, we'll just use the formula x sub 2, or the absolute value of x sub 2 minus x sub 1, and that is for the change of x, or the other term is the increment of x. Or another formula, you can interchange the formula. We can have the absolute value of x sub 1 minus x sub 2. The answer will not matter because of the absolute value, which will result to always positive, since the distance is always positive, or the distance is a non-negative measurement. So if we're going to find the distance from A to B, let's say this one, since this is horizontal, so we're going to use the increment of x, or the change of x. So if we're going to find the distance from A to B, we'll just use the increment of x, and that is the absolute value of x sub 2 minus x sub 1. So if we're going to find the distance, just substitute the values of x's. So for B, we have 4. Let us denote 4 as our x sub 2. And for our A, let us denote this one as x sub 1. Or you can have x sub 2 as our 1 and x sub 1 as our 4. So either way, we will come up with the same answer, since we are using the absolute value, or we're just taking its absolute value, which is always positive. So we have here the distance from A to B is equal to the absolute value of x sub 2 minus x sub 1, or you can have the absolute value of x sub 1 minus x sub 2. So to find the distance, just substitute the values. So we have the absolute value of 4 minus 1. So our x sub 2 is 4 and our x sub 1 is 1. Or you can have the x sub 1 is 1, or the x sub 2 is 4, or the x sub 2 is 1, or the x sub 1 is 4. So we have here the absolute value of 4 minus 1 is 3 units. That's the distance from A to B. But we can find the distance or get the distance from A to B by just counting. So from A, we're just going to count 1, 2, 3. So 3 units. The distance from A to B is 3 units. So that's how to get the distance of a horizontal line. So next is the change of y. So the change of y, since it's the change of y, so we are referring to its y values. So the formula is y sub 2, or the absolute value of y sub 2 minus y sub 1, or absolute value of y sub 1 minus y sub 2. Okay, so let's say if we're going to find the distance from A to B or B to A, since it is vertical, so that's the change of y. So the formula we have here, the distance from A to B is equal to the absolute value of y sub 2 minus y sub 1, or the absolute value of y sub 1 minus y sub 2. So you can have 5 as our y sub 2 and 1 as our y sub 1, or y sub 2 is 1, then y sub 1 is 5. So again, either way, we'll come up with the same answer. So we have here, substitute the values of y's. Then we have the absolute value of 5 minus 1 is equal to the absolute value of 4. And the distance from A to B is 4 units. Again, we can get the distance by just counting. So from A to B, we just count 1, 2, 3, 4. So 4 units. The distance from A to B is 4 units. So that is for vertical distance. So let's have an activity or a practice exercise to test your skills. So we're going to determine the distance between the 2 points. So we have here points P and S. So we're going to determine the distance from P to S. So how are we going to get the distance from P to S? Again, since it is a vertical distance, so we're just going to use the increment of y. So the increment of y, that is the distance from P to S, is equal to the absolute value of 5 minus 1. Our x sub 2 is 5, and then the y sub 2 is 5 and y sub 1 is 1, or y sub 2 is 1, then the y sub 1 is 5. So again, either way, we will come up with the same answer. So just simplify. The absolute value of 5 minus 1 is equal to 4 units, or the distance from P to S is equal to the absolute value of 1 minus 5, and that is equal to the absolute value of negative 4. So the absolute value of negative 4 is 4. So the answer is positive. So that's why we just come up with the same answer. What is enclosed in the absolute value, it is always positive, since there is no distance that is negative. When you say distance that is non-negative, or that is always positive. How about number 2? So determine the distance between the 2 points. So now, what is the distance between the 2 points? From A to B. Is it 4? Nope. 2? Nope. Okay, that's 3. You're right. 3 is the distance from A to B. So how did you come up with this answer? So again, that is a horizontal distance. So we'll just use the increment of x. So distance from A to B is equal to the absolute value of negative 5 minus negative 2. So our x sub 2 is negative 5 and our x sub 1 is negative 2. So just simplify. Absolute value of negative 5 minus negative 2. Negative times negative is positive. So that's why it's the absolute value of negative 5 plus 2. So simplify. The negative 5 plus 2 is negative 3. So we'll have the absolute value of negative 3 is 3 units. Another solution, the distance from A to B, let's say our x sub 2 is negative 2, then our x sub 1 is negative 5. So simplify again, absolute value of negative 2, then negative times negative is positive. So that's why it's the absolute value of negative 2 plus 5. Simplify, that is positive 3. Absolute value of positive 3 is 3. So the distance from A to B is 3 units. Or by just counting distance from A to B, we have 1, 2, and 3. So 3 units. So counting is just useful if we'll have a shorter distance, but it is not applicable if we'll have a longer distance. So number 3, determine the distance between the 2 points. So what is the distance from M to N? What's the distance? Is it 6, 4, 7? Nope. The answer is 6. That's right. Distance from M to N is 6 units. So again, it is a vertical distance, so we'll use the increment of y. So we have the absolute value of 4 minus negative 2. Our x sub 2 is 4, and our x sub 1 is negative 2. So simplify, the absolute value of 4, negative times negative positive. So we have 4 plus 2 is the absolute value of 6, that is 6 units. Okay, in another solution, we have our x sub 2 is negative 2 and our x sub 1 is 4. So we have here negative 2 minus 4 is negative 6. So the absolute value of negative 6 is 6 units. So again, by just counting, we'll just count 1, 2, 3, 4, 5, 6. So 6 units. The distance from M to N is 6 units. So again, counting is only useful if we'll have shorter distance. Now, in this example, determine the distance between the 2 points. We have here points A and B. So can we use the distance, or can we identify the distance between the 2 points A and B? Can we use the increment of x? Yes, that's right, because the increment of x or the change of x can be useful or can be used only if we have a horizontal distance. Therefore, it's the increment of x or the change of x is not useful in getting the distance. How about the increment of y? Again, the increment of y cannot be used in getting the distance from A to B, since the increment of y can be used only if the distance is vertical. So how are we going to get the distance from A to B? Okay, so to get the distance from A to B, that will be our main focus of this lesson. We will just use the distance formula. Before we'll apply the distance formula, let us first derive the formula. So how are we going to derive the formula? If we are going to find the distance from point A to B, and that is a diagonal line, first thing to do is we're going to denote first our point A with the coordinates x sub 1 and y sub 1. then point B with the coordinates x sub 2 and y sub 2. The next step, we're going to draw a horizontal line and a vertical line so that point A and point B will intersect and form a perpendicular line. So we're going to draw a horizontal line. Next, draw a vertical line, and then we will denote the point of intersection as point C with the coordinates x sub 2, y sub 2. So the coordinates for point C, or the point of intersection, is x sub 2 and y sub 1. Then let us denote the distance or the length of line segment AC. This one here, line segment AC. Let us denote the length as x sub 2 minus x sub 1. X sub 2 minus x sub 1, as you remember, this is the increment of x. Since it is a horizontal line, the length is x sub 2 minus x sub 1. Or it's the change of x. While the distance from B to C, or length BC, let us denote this one as y sub 2 minus y sub 1. Or since it's a vertical line, let us denote that one as the change of y sub 2 minus y sub 1. It's the distance from B to C, or it's the length from B to C, y sub 2 minus y sub 1. While the length of A to C, or the distance from A to C, is x sub 2 minus x sub 1. So we now have the length of the two legs. Okay, so next, let us denote the distance from point A to point B as D. Okay, D, it's the distance. So again, as you can see, what forms here is a right triangle. It is a right triangle because based on the intersection, we formed a perpendicular line. Here, this is perpendicular line. That means 90 degrees. So what forms, or what figure is being formed? It is a right triangle. So to get the distance formula, we now have a figure. So to derive the distance formula, or to get the distance formula, we will apply the Pythagorean theorem. Or what is the Pythagorean theorem? It's the square of the hypotenuse. It is now the hypotenuse. The side AB is the hypotenuse since it's the longest side. The square of the hypotenuse, so we have here c squared, is equal to the sum of the squares of the two legs. The sum of the squares of the two legs. So we have a squared plus b squared. So the hypotenuse here is d. Then we have here the two legs. It's either, for a, it's either x sub 2 minus x sub 1, or y sub 2 minus y sub 1. Or for b, you can have x sub 2 minus x sub 1, or y sub 2 minus y sub 1. Okay, so next step, we're going to substitute the length of the sides. So again, the longest side is the hypotenuse, and it is denoted as d. So we have our sides. Our c is d, then our a is x squared minus, x sub 2 minus x sub 1. That is our a, x sub 2 minus x sub 1. Substitute. Then squared. Plus, our b is y sub 2 minus y sub 1. This is our b. So y sub 2 minus y sub 1. Substitute here. We have y sub 2 minus y sub 1 squared. Okay, so we already substituted the length of our legs. So we now have d squared is equal to x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So next step, we're going to square root both sides so that what will remain in the left side of our equation is only d. So we have square root of d squared is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So what is square root of d squared? That is equal to d. And then what will remain in the left side is only d. So on the right side, we have the square root of x squared minus, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So this is now the distance formula. So we derive the distance formula. Again, the distance formula is d is equal to x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Please take note of the formula. So we'll have an example. Example number 1, applying the distance formula. Example number 1, what is the distance between the 2 points 1, 4 and negative 3, 2? Okay, for the solution, let x sub 1 is equal to 1, y sub 1 is equal to 4, x sub 2 is equal to negative 3, and y sub 2 is equal to 2. Then, substitute the corresponding values in the distance formula. The distance formula is d is equal to square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So again, substitute the corresponding values in the distance formula. We now have d is equal to the square root of our x sub 2 is negative 3, x sub 1 is positive 1 squared, then plus our x sub 2 is 2, y sub 2 is 2, this one, and then our y sub 1 is 4. Okay, so simplify that one. We now have the square root of negative 3 minus 1 is negative 4, so that's negative 4 squared, plus 2 minus 4 is negative 2, so that's negative 2 squared. And again, simplify. We have the square root of negative 4 squared is 16 plus negative 2 squared is 4. So square root of 16 plus 4 is equal to square root of 20. And using your calculator, square root of 20 is equal to 4.47 units. Okay, so the distance from points 1 to 4 and negative 3 to is equal to 4.47 units. Example number 2. Barangay Lundag resident reported the first person being infected with the COVID-19 and considered as PUI, and the location is at 17. If Dawn's house is located at negative 4, negative 8, how far is her house from the house of the person under investigation? If one unit on the coordinate plane is 2 kilometers. For the solution, let x sub 1 is equal to 1, y sub 1 is equal to 7, x sub 2 is equal to negative 4, and y sub 2 is negative 8. Next step, substitute the corresponding values in the distance formula. So the distance formula, we have d is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Again, substitute the corresponding values in the distance formula. Our x sub 2 is negative 4, our x sub 1 is 1, then our y sub 2 is negative 8, and our y sub 1 is 7. So substitute, we now have square root of negative 4 minus 1 squared plus negative 8 minus 7 squared. Simplify, we have negative 4 minus 1 is negative 5. So we have negative 5 squared plus negative 8 minus 7 is negative 15. So negative 15 squared. Then simplify, negative 5 squared is equal to 25 plus negative 15 squared is equal to 225. So that will become square root of 25 plus 25. Then simplify, 25 plus 225 is square root of 250. So by using your calculator again, just input square root of 250 in your calculator. The result would be 15.81 kilometers. So since 1 unit on the coordinate plane is equivalent to 2 kilometers, therefore, the distance of dawn to the person under PUI will be 15.81 times 2, that is equal to 31.62 kilometers. So the distance from dawn to the person under PUI is 31.62 kilometers. So I think that you've already learned how to get the distance between the 2 points. It's either horizontal, vertical, or diagonal. So now, answer activities 1 to 3 and the post test of your module 13 deriving the distance formula. For 15 minutes, answer the activities 1 to 3 and the post test of your module 13 deriving the distance formula.
A few moments later.
Okay, so that's it, guys. During this time of pandemic, distancing is one way of being safe. Social distancing is very important and should be implemented anywhere. What should be the appropriate distance to protect yourself from being infected and to prevent the spread of the virus? So no need of using the distance formula. At least 2 meters away from each other is enough to protect yourself and others from the spread of the virus. So once again, good day, and not like the distance formula, being always positive, you better stay negative.